All right. Today we are starting a new unit. So this is what you have. It's Unit 6, Graphing and Solving Systems of Equations and Inequalities. I know, try to contain the excitement. All right. So it's exciting, isn't it? All right. So let's see. Let's look at page 1 and see what this stuff is all about. All right. So while you're turning to page 1, let's see what this unit is about. All right. Now, what is a system of equations? A system of equations is two or more equations with two or more variables. We're not going to go over two, but if you get to like pre-calculus, you'll see equations that have more than two variables. You can have 50 variables, but we're just going to stick with two. Now, the solution of a system, graphically, it's the point where two lines intersect. You'll see what that means in a minute. Algebraically, it's the point that makes both equations true. Now, if you need to write that down, hit pause. But if you're quick at writing that down, I want to show you an example of what a system of equations looks like. Now, on the back, I wrote this on the back of the packet. This is a system of equations. Notice we've got two equations with two variables. We've got an x and a y there and an x and a y there. And the question is 7, -1 a solution? In order to be a solution, both of these equations must be true. Both have to be true. Now, what does that mean to be true? Well, let's look at the first equation. We're going to take the first equation and plug in 7 for x and -1 for y. We're going to see, does that come out to 31? Let's plug in 7 for x, -1 for y. 35, that's 5 times 7, plus -4, that's 4 times -1. Is that equal to 31? Well, 35 minus 4 is 31, so it worked. But it has to work in both equations. It can't just work in one. So we need to look at the second equation. 2 times 7 minus 3 times -1. Is that equal to 10? That's the second equation. All right. 14, a negative times a negative is a plus. Is 14 plus 3 equal to 10? No, it does not. So since it does not make both equations true, 7 -1 is not a solution because it does not make both equations true. It has to work in both. Now, I'm not going to spend too much time on the first method for solving because we're just going to do this part on Desmos. I'm not going to make you graph these by hand. But three things can happen. The lines could intersect. All right. They don't have to be perpendicular. As long as they intersect, there's the solution right there. So if the lines intersect, you have one solution. But what if you have parallel lines? They don't intersect at all. So that would be no solution. All right. Again, if they intersect, they do not have to be perpendicular. They can be, but as long as they cross, that's all that matters. The last thing that could happen is if you have the same line. If the two lines are right on top of each other, then that means there are infinitely many solutions because they are always crossing each other. Okay. Now, let me show you how to solve by graphing. You're just going to graph both lines on the same coordinate plane. That means you're going to put both lines on the same graph, and you're going to find where the lines intersect, hopefully. All right. So let me show you how I'm going to do that. We're going to actually do this on Desmos, all right? I'm not going to make you graph these equations by hand. All right, so on Desmos, we're going to solve, when you solve these by graphing, you're just going to use Desmos to do it. Okay, so let's do this first one right here on Desmos. All right, so we're going to type that in. Let me share my screen. Let's see. Here we go. All right, you should be able to see Desmos now. All right, I'm going to show you how to solve that first one, but you're just going to type in y equals x minus 8 on one line. That's the first equation. Then you're going to type y equals negative 2x plus 1 on the second line. And right here is where the two lines cross. They cross at 3, negative 5. They cross at 3, negative 5. So all you got to do now is say, well, what did the two lines look like? They looked like, all right, they looked basically like, I don't know, they looked like this, but they crossed at 3, negative 5. So all you do is type it on Desmos and click. Type and click. All right. Let me show you something else that can happen. Let's look at an example on the second page. All right. Let's look at number 6. Look at number 6 right here. Now that looks weird. F of x equals x minus 2. Really, remember, f of x is just a fancy way of writing y. So when you type it in, you're not going to type f of x and g of x. You're just going to type y. So if I type both of those equations in, let's see what the solution to number 6 is. All right, so let me share my screen again. We're going to go to Desmos. All right, let's go to Desmos. And well, I still have the last problem on that screen. So I'm going to click and turn those off or erase those. And we're going to type in the problem we're working now. Y equals x minus 2. And the next question, the next equation was y equals x plus 5. Now, those are parallel. They do not intersect at all. So what do you write when they don't intersect at all? Okay, what happens when they don't intersect? All right, what happens when they don't intersect? All right, those two lines look something like this. They were parallel. They don't intersect. So you would write no solution. All right. So if they cross, you just click and write down where they cross. If they don't, you write no solution. I don't see one right offhand. Oh, number 4. Let's do number 4. This will be the last one we do by graphing. Now, normally when you are graphing them yourself, you'd have to solve for y. But if you're using Desmos, you don't have to isolate the y. You don't have to do that. You can just type the equations in the way you see them. So let's do that one on Desmos. All right, let's do that one on Desmos. All right, so Desmos, what does that look like? All right, let's get rid of the last problem we did. All right, so the first equation is x plus 2y equals 4. X plus 2y equals 4. The second equation is y equals negative 1 over 2. Just use the backslash, but make sure you toggle over and put the x beside the 1/2. Make sure the x is not in the denominator with the 2. If you put the x right here, it's wrong. You got to put the x beside the 1/2 and then plus 2. Note those two lines are right on top of each other. They're right on top of each other. So that's an example where you have an infinite number of solutions, okay? So that one looked like this. Both lines were right on top of each other. So that is infinite solutions. It has an infinite number of solutions. So that's how you solve by graphing. And since we're doing it on Desmos, it's very simple.